Hello everyone, I'm T. Giridhar Reddy. I'm a fourth year undergraduate in IIT Tirupati. This is the technical paper presentation as part of our medical imaging course. So today I'm going to discuss about the paper based on HydraMixNet. Let me first introduce you about the HydraMixNet. HydraMixNet is a semi-supervised learning approach. So what are semi-supervised learning approaches and why have they become famous recently? So to achieve the state of art performance in general, it is almost confirmed to train models as single task learning on large scale datasets with their associated labels. But the costs associated with labeling of the datasets, especially for medical imaging data, which involves expert knowledge to correct the ground truth, is often very high. In contrast, semi-supervised learning approaches, that is SSL approaches, take advantage of the limited data and utilizing the readily available unlabeled data to improve the model performance. Now, let us discuss about the approach of semi-supervised learning techniques. Semi-supervised learning techniques follow a two-step approach. Firstly, they predict pseudo-labels for unlabeled data from the model trained on limited label data. And then they retrain the model on pseudo labels and limited label data to improve the performance. So now we'll discuss about problems in SSL approach. The problems are as follows. The first one is that the decision boundary passing through high density regions. And the second one is that network not knowing if the input was being altered in some ways. Example is rotation, that it is rotated or not. And the third one is that semi-supervised learning approaches also suffer from noisy labels as the pseudo labels can introduce noise in the training batches. The purpose of semi-supervised task is to learn from unlabeled data during learning such that it improves the model's performance. To achieve this goal, SSL approaches take advantage of different techniques to mitigate these above discussed issues faced during learning. Examples are consistency regularization, entropy minimization, and noise reduction. Now we'll discuss about the main contributions of this paper. The first one is a novel multitask SSL framework, HydraMixNet, is proposed for cell detection and classification, which is used for simultaneous detection and classification of cells and enabling end-to-end learning in a semi-supervised manner, and also to improve the performance of a semi-supervised approach by enhancing a single loss term with noisy labels for joint training of multitask problem using symmetric cross entropy loss function. So now let us discuss about the dataset used here. So in general, SSL approach is to alleviate the need of time-consuming and laborious tasks of manual labeling for histology whole slide images WSI. In this regard, they opted to use diffuse large B-cell lymphoma DLBCL data because manual annotation of cell type and nuclei localization is very hard due to the large number of cells present in WSIs. DLBCL malignancy originates from B-cell lymphocytes, and it is the most common high-grade lymphoma among the Western population with poor disease prognosis. So the patches of 41 cross 41 were extracted from 10 manually annotated WSIs, resulting in 12,553 patches, and after applying online augmentations, 24,000 patches were used for this study. 3 WSIs were selected for the test purposes, while 7 WSIs were used for the training purposes, splitting on 70-30 basis, which resulted in 18,000 training patches and 6,000 test patches. Now let us discuss about HydraMixNet model. So the proposed semi-supervised method, HydraMixNet, is the approach consisting of different multitask and semi-supervised techniques to handle various learning issues. such as consistency regularization using standard augmentations and mixed up techniques, entropy minimization with the help of sharpening, and handling noisy labels with the modified loss terms like symmetric cross entropy loss, SCE loss. The proposed HydraMixNet jointly optimizes the combined loss function for classification and localization of centroids for the cell patches. This proposed multitask learning framework consists of a backbone model with three heads responsible for the classification and regression, that is, the localization of the cell nuclei. So here, this is the schematic diagram of the proposed HydraMixNet. So this is the unlabeled data UB and this is the labeled data XP. So first we take the unlabeled data UB, which is subjected to K augmentations to generate a U-BK. And we take this U-BK and then process them from model, this CNN model, to generate pseudo labels, after which the predictions are averaged and also sharpened to minimize the entropy in the prediction distribution. Once the pseudo labels are assigned, and then we mix them up with label data XP to help model iteratively learn more generalized distributions with noise suppression. And from steps 2 to 7, they happens to repeat for after every epoch start. And let us discuss about experimental settings. Experimental settings used to test the effectiveness of the proposed approach were fully supervised, partial data, semi-supervised. The first one of all the available data was used to train a simple CN, that is HydraMixNet, while in partial setting, HydraMixNet was trained on partially labeled data. Lastly, HydraMixNet used semi-supervised approach for training where both labeled data and unlabeled data are used. So the results are as follows. You can see for the high label data, such as when we are using 3000 label data, CNN works fine, which is expected as it gives state of art performance when it has large data. But when you have small data like below 10, like 1000 label data, you can see that the CNN model perform poorly. But the HydraMixNet looks to be best model yet so far, where when we have small label data, which is very useful when we are handling with medical imaging data, as we have few number of label data there. Having unlabeled data, we can use HydraMixNet, where we can make pseudo labels for the unlabeled data by training on label data, and use them to use the labels for the unlabeled data to train along with the label data, because to label the unlabeled data manually, the cost related is very high to this. So let us come to the conclusion. So we discuss about briefly about how SSL techniques were used and how they help to detect and classify when we have small amount of data, and also predict labels for unlabeled data. We also discussed about the novel end-to-end holistic multitask semi-supervised learning approach, HydraMixNet, for simultaneous classification and localization of nuclei and in DLBCL. So that's it for the presentation. Thank you.